Hello everyone, in this video I will continue the numerical of open channel flow, uniform flow. This was asked in 2014 chance in 3B in 8 marks. The question is a hydraulically efficient trapezoidal channel. This is trapezoidal channel with side slope 1:1. Horizontal is 1 and vertical is also 1, so the value of Z is 1. It is required to discharge 14 meter cube per second with a gradient. Discharge is 14 meter cube per second with a gradient. Slope is 1 in 1000, that is 1 divided by 1000. If online, so there are two cases. One is this online case, the value of Z is 45, and in line with concrete the value is 70. So there are two cases. If the least cost per meter cube of the excavation is 3 times the cost per meter square of lining, let the cost per meter square of lining, the value is not given, so it is X, and cost per meter cube of excavation. Cost per meter cube of excavation is 3 times cost per meter square of lining. Cost per meter square of lining, which is 3 times X. So for this hydraulically efficient trapezoidal channel, we have B plus 2yz. This is top width is equal to 2 times this side length. Since Z is 1, so B plus 2y is equal to 2y. 1 plus 1 square is 1 plus 1, which is root 2. So B is 0.828y, and R is equal to y divided by 2 for this efficient, and area is B plus yz. Z is equal to 1, so B plus y. B is 0.282y plus y times y, which is equal to 1 plus 0.828 is 1.828y, and this y makes y square. So for first case, for online, the value of Z is C is 45. C is 45, and this is the formula. Z is equation. Q is given in question 14, and A we have already calculated. R is y by 2, and slope is 1 divided by 1000. This 1 divided by 1000. So y is 2.252 meter. From equation I, B is equal to 0.828y. Y is 2.252, so B is 1.865. Considering 1 meter length of channel, if this is channel, then in 3D it will be like this So amount of excavation is this area multiplied by length. If this length is 1 meter, amount of excavation is, or volume is, area into length. Area is 1.828 y square and length is 1, so y is this 2.252, so area is 9.271. This is the volume is 9.271 meter cube. And total cost of excavation is amount of excavation or volume of excavation into cost per meter cube of excavation, that is amount of excavation 9.271 and cost of excavation is 3 times the cost of lining, 3x, that is 27.812 years. This is the first case. And in another case, C is if lined with concrete, the value is 70. The value is 70. So y is 1.887 meter. So from equation 1, b is 0.828y, y is 1.887, so b is 1.563, and area is this. By putting this value of y 1.887, area is 6.509. Cost of excavation is volume times cost per meter cube of excavation, that is rate. This is area, this is length, which is volume, and this is 3x is rate. So 19.527 is the cost of excavation. Cost of lining is lining is done in here, and here. This is perimeter or weighted perimeter, that is this is B, this is y root under 1 plus z square, and there are 2, so two sides. Length we assume 1, and cost per meter square of lining we assume x, so cost of lining is this much. Total cost is cost of excavation plus cost of lining, that is 19.527 plus 6.9, that is 26.47. And here is x. In first case, the cost is 27, and in second case the cost is 27. So this is less. That means lined canal is less. Since total cost of lined canal is lesser than total cost of unlined channel, so lined channel will be cheaper. So its dimension are this bottom width is 1.563 and depth is 1.887. This is the required dimensions, and this was asked in 2014. A trapezoidal channel. This is a trapezoidal channel. Carries a discharge of 142 meter cube per minute. In 1 minute, the discharge is, the volume is 142. So in 1 second, the discharge, the volume will be divided by 60. 142 divided by 60. So 2.367 is the volume per second, and is designed to have a minimum cross section. So this cross section should be minimum. Find a bottom width and depth if the base slope 1 in 1200, that is 1 divided by 1200. Side slope is 45 degree. 45 degree is always from horizontal, that is 45. So from vertical also it is 45. So that means this is, the vertical is 1 and horizontal is also 1. So Z is 1 for and C is C is 35. Yes. So for most efficient channel, or for channel with minimum cross section, b plus 2yz is equal to 2y1 plus z square. B plus 2yz is 1, so b is 0.828y. So area is by plus zy square, which is z is 1 and b is 0.828y. So 0.828y and this y is y square. That means 0.828y square plus y square is 1.828y square. Q, this is minus for this formula. Q is AC within the areas. Q is, we have already calculated, 2.367 is equal to area is 1.827 y square. C is 35. R is y by 2 for this condition, and S is 1 by 1200. Y is 1.267, which is nearly equal to 1.27. From equation 1, B is 0.828y and y is 1.267, so B is 1.05. So bottom width B is 1.05 and depth y is 1.27. So this, we need to calculate bottom width and depth. So bottom width and depth are this, and this is the last question, which was asked in 2010 in 8 marks. A rectangular channel, rectangular means this. A rectangle channel 4 meter wide, width is 4 meter and has depth 1.5 meter. Depth is depth of water. Y is 1.5 meter. B is 4, Y is 1.5. The slope of bed of channel is 1 in 1000, that is 1 divided by 1000, and Z is constant, C is 55. It is desired to increase the discharge to a maximum. So from this dimension the discharge will be, let's say, Q. So it is desired to increase the discharge to maximum. Next case is Q max by changing dimension, this and this, by changing of the section for constant area of cross section, but this area should be constant by changing this and this, but the area should be constant. Slope of bed is 1 by 1000 should be also constant, and roughness of channel C should be also constant. Find new dimension. We need to calculate new y and new b of the channel and increase in discharge, that is del Q. It's equal to Q max minus Q. First of all, we calculate the area. Area is B into Y. B is 4 and Y is 1.5. 4 into 1.5 is 6. And perimeter. perimeter is this is weighted perimeter is this. This is rectangular channel. Weighted perimeter is this. This is 1 point. This is y plus this is b plus this is y. Y plus b plus y is b plus 2y. B is 4 and y is 1.5. 2 into 1.5 is 3 and 4 7. R is A divided by P. A is 6 divided by P 7. So R is 0.857. Q is AC root under areas. Q is AC root under areas. Area is 6. C is 55. Root under R is 0.857 and yours is 1 divided by 1000. So discharge is 9.66 meter cube per second. And the next is for the condition of maximum discharge. This most efficient channel R is y by 2 and B is 2y. So area is B into y. B is 2y and y, 2y square. Since in question by changing dimension of section for constant area of cross section, area of cross section is 6. So in this case also area should be 6. 6 by 2 is 3. Root of 3 is 1.732 meter. So B is 2y. 2 into 1.732 is 3.464 meter. R is y by 2. 1.732 divided by 2 is 0.866 meter. So Q max is AC root under areas. So Q max will be 9.71. Maximum should be greater than Q. 9.71 should be greater than 9.66. So increase in discharge is Q max minus Q, that is 9.66. 9.71 minus 9.66, that is 0.05 meter cube per second. And all that is we need to calculate dimensions of the channel with this maximum discharge. So dimension is width B is 3.464 and depth is 1.732. So thanks for watching. Like, share and subscribe the channel. If there is any doubt or mistake, then let me know in comment section. Thank you.